Hello everyone, welcome to Chem Analysis. In today's question answer discussion video, I will solve previous year CSIR-NET December 2017 Organic Chemistry questions, and that are for 2 marks question, and in this video I will solve 10 questions. I have already uploaded 2 videos describing the solution of the inorganic and physical questions of previous year CSIR-NET December 2017. So if you have not watched that video, I will give the link in the description box, you can watch. So let's start this discussion. The first question, we can see that we have to identify regarding this molecule that the molecule has any plane of symmetry, any center of symmetry, or the absolute configuration of this compound. Now we can see that this is a alene type molecule, and since these two groups are different and similarly these two groups are also different, so it is optically active. There is no sigma plane or any center of symmetry, so these two options is cancelled out, and we have to see what is the stereochemistry of this compound. To solve the stereochemistry of such alene or binaphthyl compound, generally you have to see the molecule from that side in which the two groups are in plane, or from the opposite side in which the two groups are above the plane and below the plane. You can use any technique, but here I will tell about only one technique that I used to do. I mainly used to solve such type of questions by viewing the molecule from the side in which both the groups are in plane. That means if you see the molecule from this side, then what you will see? You will see that on the right side of you there is CO2H group, and on the left side there is hydrogen atom. And since you are viewing this molecule from this side, these two groups will be on the horizontal axis, and the horizontal axis is denoted as solid bond, and on the right side you will see CO2H group, on the left side hydrogen atom. And if you see the molecule along this axis, then what you will see that this CO2H group is above the plane and this hydrogen atom is below the plane with respect to you. That means along the vertical axis, on the above axis, what will be the group? CO2H, and on the below axis there will be hydrogen. Now you have to numbering the group, and during the numbering you have to give the priority first the horizontal groups along which you are viewing the molecule. So among the horizontal groups, this one will be 1 and hydrogen will come later, so hydrogen will be 2. Now we have to go to the vertical group, and in the vertical group you can see that this CO2H group will be 3 and this will be 4. Now you have to just see the rotation from 1, 2 and 3. If it is clockwise, then the stereochemistry will be R. If it is anti-clockwise, then the stereochemistry will be S, irrespective of the orientation of this fourth prior group. That means in this case it is not similar to the normal RS nomenclature, since in the normal RS nomenclature, if the fourth priority group is on the horizontal side in horizontal plane, then the stereochemistry will be just opposite. If the rotation from 1 to 3 is clockwise, then the stereochemistry will be S instead of R, and if the rotation is anti-clockwise, then stereochemistry will be R instead of S, provided that the least prior group is along the horizontal axis, and it is for normal determination of RS nomenclature, not like in binaphthyl or such alene system. So here we have to just see the rotation from 1, 2 and 3. If it is clockwise, then it will be R. If it is anti-clockwise, so it will be S. Here we can see that the rotation is clockwise, so the stereochemistry of this group will be R. Is it okay? Later I will also upload a video for the stereochemistry determination of optically active compound, where I will discuss all the related information related to the stereochemistry determination. So let's see another question. Here it is given that it is beta-naphthol, and we have to identify the kinetic product. Here it is given as kinetic product formed in the sulfonation reaction of beta-naphthol. Now since OH group is ortho and para-directing, so in this beta-naphthol we can see that this is the ortho position, this is the ortho position to OH, and the para position with respect to this phenolic OH for this ring is this one, but since this position is blocked, for the naphthyl case, beta naphthol case, we can think that this position is the para position with respect to OH group. That means electrophilic substitution can occur at this 3 position. If it is 1, this will be 3, and 4, 5, 6, this will be 6. Now it is seen that the electron density at this C1 carbon center is highest among the 3 and C6 carbon atom, and due to the higher electron density at the C1 center, electrophilic substitution, that is sulfonation reaction, occurs rapidly, that is kinetically favored product occurs at the C1 position to give the 1 sulfonic acid substituted beta naphthol. So it will be the kinetically controlled product, that means the product which will form at a faster rate than the other possibility, and 4 will be the correct answer. And in this question we have to tell about the most stable structure for the given compound. Here we can see that this methyl group and this OH group are above the plane, that is on the same side. And if we draw this structure in chair form, then we can see that this structure, that 2 option is not correct, since methyl and OH group is in opposite direction, that is not on the same side of the plane. Methyl is above the plane, OH is below the plane, and similarly 4 is also not correct. Here methyl is above the plane, OH is below the plane. Now between 1 and 3 structure, if we draw the first structure, this and methyl, both the methyl and OH group are above the plane, and here will be hydrogen, one axial and one equatorial. And if we draw the other structure, here is OH above the plane, and here methyl is also above the plane, and here will be one hydrogen axial, one equatorial. Here hydrogen will be axial and another hydrogen equatorial. Now between these two compounds we can see that in one structure OH group is above the plane, and in the another structure, it is structure 3, in another structure methyl group is above the plane. Now in this 3 structure we can see that there is 1,3 diaxially oriented hydrogen atom at the 3 position with respect to this methyl. So there will be 1,3 diaxial interaction with this methyl and hydrogen atom. There is 2,1,3 diaxial interaction, but in this case we can see that in the third position there is no axially oriented hydrogen atom as like this structure. And for the second position, if we try to see the steric repulsion, then we can see that the hydrogen atom is below the plane but OH is above the plane, and the above the plane hydrogen atom is equatorial, so it will not exert any steric repulsion with this axially oriented OH group. And though in the third position there is 2 lone pair electron on the oxygen atom, but they are not axially oriented, so there will be less steric repulsion in this structure 1 with respect to structure 3. So we can say that structure 1 is the most stable conformation of given structure A. So 1 will be the correct answer. Here I want to mention also one thing, that the steric effect that is determined by A factor of methyl is greater than that of A factor of OH group. Though this is not playing any role in this case, since there is no 1,3 diaxial interaction with this OH group for which this value is required. So it is just for a information. Now here it is a question from pericyclic, and we have to tell about the HOMO, that is highest occupied molecular orbital of this hexatriene in this reaction. And here we can see that the reaction is occurring photochemically, and since in the hexatriene there is 6 carbon atom, there will be 6 molecular orbital, and if we number them like this, the number of molecular orbital is equal to number of carbon atom present in the compound. So if we put the electron in the molecular orbital, since there is 6 electron in this molecule, so the electron will be filled up till psi3. And if we consider the HOMO in thermal condition, the HOMO will be psi3, that is highest occupied molecular orbital in thermal condition. But since the reaction is happening at the photochemical condition, in photochemical condition one electron will be excited to higher energy state, and the electronic distribution will be like this. The remaining orbital will be filled up as this. So we can see here that the highest occupied molecular orbital HOMO is equal to, in this case, SOMO, that is singly occupied molecular orbital, and HOMO for this hexatriene molecule under photochemical condition is psi4. And if we consider the node for this HOMO, then there will be 3 node, n minus 1. So from the given molecular orbital picture we have to count the number of node, and in which there will be 3 node, that will correspond to the HOMO for this hexatriene. In this respect one information is necessary, that is node is the point where the wave function changes its sign, or in other words we can say that the point where two orbital overlaps with opposite symmetry. That means for the first case we can see that here is one node, since the orbital overlapping are opposite symmetry, this is not node, it is also not, and here is another node, so there is 2 node in this case. Similarly for the second case we can see that here is one node, here is one, so in this case also there is 2 node. For the third case we can see that there is only one node, and in the fourth case we can see here is one node, here is one, and here is one, so there is 3 node for the fourth case. And in the HOMO there is also 3 nodes, so we can say that 4 is the HOMO for this hexatriene molecule under photochemical condition. It is very important, the condition. If it is thermal, then the HOMO will be psi3 and node will be 2. So is it okay? So next, go to next question. And for this question I want to say that to calculate the number of 13C NMR signal or proton NMR signal in NMR spectrum, I have already uploaded 3 videos where I have discussed different type of questions, and this question is also discussed in my previous video. I will give the link for detailed solution or detailed discussion, you can watch that video. So I am just telling here the answer, what will be the answer. In this case we have to identify the number of 13C NMR peak NMR signals in the 13C NMR spectrum for this molecule, and the answer will be 5. So let's try to solve by yourself. If you feel any difficulty, then you can go through the link given in the description box. Similarly, I have also solved this question in my previous video on NMR spectroscopy, so you can also watch the solution for this question from my previous video. And the answer for this question, we have to identify the structure, correct structure depending on this proton NMR value, and the answer will be this option number A, since there is 3 type of proton, and in this compound there is 3 type of proton. So next, see another question. Here we have to tell about the basicity of this following heterocycle, and for the first one we can see that it is a pyrrole molecule, and the other case also there is a pyrrole moiety, along with there is one heteroatom within the structure. So the lone pair on the nitrogen atom take part in resonance with the 2 pi bond, and all the 3 compounds shows aromaticity for the involvement of this nitrogen lone pair, and in that case it will behave as a 6 pi electron, that is 4n plus 2 pi electron system. So all the 3 compound will be aromatic, and along with that we can see that these two compound B and C contains two heteroatom, and due to presence of lone pair on this heteroatom, since nitrogen will also contain lone pair, due to presence of this lone pair on this heteroatom, they will show more basicity than this compound, since here is no such lone pair containing heteroatom. Now between these two structure we can see that this nitrogen is at the alpha position with respect to this nitrogen, and in this case it is, if we consider it is as beta position, that is if we number it, it will be 1, it is 2, and it is 1, and this nitrogen is at the 3 position. So here we can see that the distance between this nitrogen center and the donor nitrogen center is more in this C structure than that of B. So minus I effect, that is electron withdrawing minus I effect of this nitrogen on this donor nitrogen atom will be less in C than that of B. As a result, the lone pair electron on this nitrogen can be donated in greater extent than that of this nitrogen lone pair. So C can donate electron at a faster rate than that of B, and that can donate electron at a faster rate than A, and simply A does not contain any lone pair to donate. So A will be least basic and C will be the highest basic. So the basicity order will be like this: C is greater than B is greater than A. So you can see that 3 is the correct answer. And here we have to tell about the stability order for this carbocation. Here we can see that all the 3 carbocation is tertiary, and there is 2 methyl group in all the 3 cases attached to this carbocationic center. So the stability effect, that is plus I and hyperconjugating effect for this 2 methyl group will be similar in all the 3 cases. So we can neglect this effect for stability determination. And now on the other case, here is OMe, CH2OMe, and in the third case the oxygen will contain 2 lone pair. In all the 3 cases oxygen will contain 2 lone pair. Now in this case we can see that oxygen can exert its plus R resonance effect to stabilize this carbocation, and similarly in this case also the pi bond can enter into resonance to stabilize this carbocation, but here is no such resonance effect. There is only hyperconjugating of these 2 hydrogen atom and plus I effect of this alkyl group, but stabilizing effect, that is plus R effect, is more stabilizing than plus, that is hyperconjugation effect, and that is far more stronger than the inductive effect. So we can say that B and C will be more stable than that of A, since in A there is no resonance effect. It is methyl. Now between the stabilizing resonance effect of B and C, since in C the lone pair is taking part in resonance and in B the pi bond is taking part in resonance. Now if you see the energy distribution of pi and non-bonding electron, then pi bond will be lower in energy than that of non-bonding electron, and here will be sigma, here will be pi star, and at the last will be sigma star. So since energy of the pi electron is less than that of non-bonding electron, so reactivity, that is stabilizing effect of pi electron, will be less than that of non-bonding electron. Since the energy of pi bonding electron is less, it will be more stable in comparison to the non-bonding electron. That means it will be less reactive, so it will less interact with the carbocationic center and less stabilize this carbocation. So the stability of the carbocation in this C case will be higher than that of B, and the least stable is A. And in another way, you can also think that oxygen lone pair is donating, the hybridization of oxygen is sp3, and here the pi bond is entering into resonance, that is sp2 hybridized carbon atom is sp2 hybridized, and since sp2 carbon center is more electronegative than that of sp3, so involvement of the pi electron for this sp2 center will be less than that of sp3 center, and depending on this reason also you can tell that C will be more stable than that of B. So the order is CBA, so option number 4 is the correct answer. Here we have it is given a diketo compound and it is treated with a strong base potassium hydroxide, and we have to tell about the product of this reaction. Now here we can see that there is 3 type of acidic CH bond, that is this is one acidic CH bond, this is also acidic, and this is also acidic. Let's draw the structure first. Now if the base abstract this acidic proton, then here will be anion, and that anion can attack at this carbonyl center to form a 1 2 3 4 5 6 7 8 member ring. On the other way, if the base abstract this CH proton, then here will be anion and it can attack here to form the 8 member ring, but the stability of 8 member ring is less than that of 6 member ring, and that 6 member ring can be formed when the base abstract this acidic proton, and therefore here will be anion, and this anion can attack at this carbonyl center to form a cyclic ring that will be 1 2 3 4 5 6 member ring. So this acidic proton will be abstracted and it will form the cyclic product, since 6 member ring is more stable than that of 8 member ring. So option number A 1 and 2 is not correct, since here is forming 8 member ring. So between 3 and 4 we have to see which will be the correct structure. Here we can also see that here is no acidic proton, so the possibility of abstraction here is not possible. So if base abstract this acidic proton, then here will be anion, and that anion can be stabilized by resonance with this carbonyl group. One, two, three, four, 5, 6. 1 2 3 4 5 6. Okay, so in the next step this O minus will form here double bond, and here will be anion. That anion will attack at this carbonyl carbon to open up this carbonyl group. So here will be formation of 1 2 3 4 5 6 member ring. And in the next step methanol will protonate this OH group, and there will be dehydration, and dehydration will occur from this side, since here is one acidic hydrogen. It will liberate, and after protonation it will become OH2 plus. So here carbon hydrogen bond will break here, form double bond, and OH2 will be liberated. So there will be formation of such alpha beta unsaturated ketone. Since at this carbon center there is no hydrogen atom, so double bond cannot be formed here. On the other way, the double bond here will be stabilized due to conjugation with this carbonyl group. So we can see that option number 3 is the correct answer. If we draw it like the given structure, so it will be like this. So you can say that 3. We can see that 3 is the correct structure. So this is the last question for this discussion, and it came from IR stretching frequency. We have to tell about we have to match the IR stretching frequency for the given compound. Now here we can see that the first compound is ketone, the second is A star, and the third one is anhydride. Now if we draw the 3 structure, and if you number it 1, 2 and 3. Now carbonyl stretching frequency for a 5-member ketone generally appears within 1740 to 1750 centimeter inverse, and for 6-member ketone it appears 20 to 30 centimeter inverse less than that of 5-member ketone. Now as we go from a ketone to A star, since at the alpha position there is oxygen atom and it shows its electron withdrawing minus I effect, and due to this minus I effect the oxygen will attract the electron density from this carbonyl carbon, and as a result the carbonyl carbon will become more electron deficient, and to compensate the electron deficiency the oxygen lone pair will enter into resonance with this electrophilic carbon center, and as a result the bond order or bond strength of this carbonyl group increases, and therefore IR stretching frequency also increases due to minus I effect of this oxygen atom. Thus 2 will have more IR stretching frequency than that of 1. Now if we see the structure 3, then here we can see that the oxygen atom will exert its minus I effect on this carbonyl group and increases its IR stretching frequency, and similarly the lone pair of this oxygen can enter into resonance with this carbonyl group, and as a result electron withdrawing power of this oxygen atom increases far more greater than that of this structure 2, and as a result in anhydride the IR stretching frequency is more than that of A star. So the IR stretching frequency order will be 1 less than 2 less than 3. So in this case we can see that 3 will show higher stretching frequency, then there will be 2, and at last there will be 1. So the order is 1 is C, 2 is B and 3 is A. So option number 3 is the correct answer. So if you feel any difficulty then let me know in the comment section, and you can also send me a mail as I have given the mail ID in this video. So thank you for watching, and if you are new in this channel then please subscribe to my channel Chem Analysis to get such interesting question answer series and other related topic. Thank you once again.